Unit 1 Chemistry, Chapter 10, Polymers. So we mentioned polymers in the last one. These are long chain molecules and they have a repeating subunit that links together. The repeating subunit is called monomer. Mono means one, poly means many. The most common way of making them is to get an alkene, like for instance ethene, and break the double bond and link them together. Okay? Because we're not removing anything, we're only adding things. It's called an addition reaction or addition polymerization. Okay? And we name them after the monomer. So if we make a polymer from ethene, we call it polyethene. So this here is polyethene. Now, if we look at it, it's got only single bonds. So you might be wondering why it has an ene ending. It's because it's a polymer of ethene. That's what the name means. Okay? If you take something like this, okay, this would be polypropene. Right? What's happened here? There was a double bond there, made it propene. Okay, 1, 2, 3 in a row. This double bond breaks and it makes a chain out the side. The part of the propene that had no double bond in it, that wasn't bonded by a double bond, becomes a side branch that sticks out the top. Okay? If you've got chlorine on it, okay, this was chloroethene, so we make polychloroethene. Okay? Sometimes this is called vinyl chloride, it's the old-fashioned name. So then we make polyvinyl chloride, or PVC. This one here, this is made from 1, 2, 3, 4 carbons in a row, with the double bond would have been between the first and the second. So this would be a polymer of but-1-ene, and we've got a chain that goes out the side, which is 2 carbons in length. This here, if we break it up, we look at our repeating subunit, 2 carbons along, always 2 carbons along, so that gives us back our monomer. So this one to this one, break it there, put a double bond back in, and now we've got 1, 2, 3, 4 carbons in a row, and a double bond between the second two. So that would be but-2-ene, so this whole thing is poly-but-2-ene. As we saw, some of them were straight lines, some of them had side branches. Okay? If the side branches are non-polar, then that means that we're going to spread out the chains, which means that we get fewer dispersion forces. Okay, because if you've got one long chain, you can get dispersion forces all along it, but they only act over a very small distance. So the branches stop them lining up close to each other, which means that we are then going to get only a small amount of dispersion forces. If it's a polar branch, then it can actually increase the intermolecular forces. Some of them make cross-linked polymers, which means the branches can actually make a covalent bond with the branch of another strand. And that, of course, makes it very, very strong. So some of these polymers are thermosetting and some are thermoplastic. If they're thermosetting, then they would tend to be cross-linked. And these are ones that if you heat them, they don't get softer. They tend to be your hard polymers, or colloquially your hard plastics. So things like the chairs that you are sitting on at the moment are made partly out of a thermosetting polymer. They've got strong bonds within and between the chains. The other type are thermoplastic, so you heat them up and they will reset on cooling into a different shape. They tend to be soft and malleable. Okay? Some of your pencil cases might be made out of a thermoplastic polymer, okay, if you've got a soft one. They tend to have strong bonds within the chain, but one chain to the next has got weak intermolecular bonds. The other way to tell if it's thermoplastic, it will have a little recycle symbol on it somewhere, because we can only recycle thermoplastic ones, because when we recycle them, we heat them and then we put them into a different shape. Now, polymers are great in some ways. They've got so many different properties because you can make different polymers with different monomers, and therefore a huge variety of uses. They've got low density, they're not going to react, so we can use them to store food in and the like. They insulate against heat and electricity. And you can make them clear, which means that you don't have to put glass in, which is of course highly breakable. But we get them from crude oil, which means that they are non-renewable. We can't get more of the crude oil once it runs out. Okay, we can't replace it as quickly as it was made, because remember it took 300 to 400 million years to make it. They take a very long time to decompose. So our landfills are getting filled with polymers. Okay, particularly the thermosetting ones that we can't recycle. You can only use them at a relatively low temperature, particularly if they're thermoplastic, because otherwise they're going to change shape on you. And some of them break down in UV light or if exposed to solvents. And when they break down, they can make things which are toxic to human health.